right now we will continue with tangent line theorems. First, I want to review quickly the first theorem that we discussed, and that guy is right here, and it says that if you have a circle and a line is tangent to the circle, P is the point of tangency. If you draw radius QP, then radius QP is perpendicular. We did lots of examples already. I want to do one more. So if we look at these four examples, all of them more or less are the same, but examples 2 and 4 might have a little extra difficulty level to them. So I think I'll do number 2. So here we want to find the radius. So here we have, and notice that lines that appear tangent are tangent. Well, this one looks tangent, so let's go ahead and make that perpendicular. Now I have a right triangle. When I have a right triangle, I can use my Pythagorean theorem, a squared plus b squared equals c squared, but it looks like I have two sides that I don't know. Remember, these are your radii, and they are the same. So I'm going to put the same variable here and here, and that way there's only one variable in our equation. A squared plus b squared is equal to c squared. This entire segment here, both of these pieces combined, is going to be r plus 10. Right? We're going to add them together. So this squared plus this squared equals this squared. Let's do it. R squared plus 24 squared is equal to the whole thing, r plus 10 squared. My left side, r squared, so 24 squared, is going to give us 576. And r plus 10 squared. Whenever I have a binomial and I have to square it, so a little space over here, let's do this, write it twice, FOIL it out. R plus 10, r plus 10. Here we go. Firsts, outers, inners, and last. 10 times 10 is 100. Combine your terms, so it's going to be r squared plus 20r plus 100. Okay, so now that I have this, I want to combine any like terms that I can. I see r squareds, probably have to factor. I'm going to get everything to the same side. And as I do that, as I subtract these r squareds, they cancel, which is fabulous because now there's no more r squared, no more factoring. Let me move this 100 over, and that's 476 equal to 20r. Divide by 20, divide by 20, and r is equal to, so pull out your calculator, and you can divide 476 divided by 20, and that's going to be 23.8. That's what your radius is. Okay. So each time they don't give you the radius, write it in both places, and this will be the scenario that happens. Same thing happens down here for number 4. This is the one with the decimal answer, and that's why I chose to do that one. Okay, so that is a review of what we've previously done. This is our new theorem for today, the external tangent congruence theorem. So this is basically what it's going to say. It says if you have a circle, and if you have a point out here, and then you draw two tangent segments to the same circle, point of tangency, then these two segments are congruent to each other. I kind of look at it as a little princess hat, so it's perfectly symmetric on either side, and then there's your like little thing on the top. So that is going to be our new theorem. So let's take a little look over here on the left. We see explain why. So this is essentially a proof. I have it written out in the answer key. You can refer to that. I'm just going to talk it out here. Basically what we are given is that you have tangent lines. I know that both of these are tangent. And since they are tangent, then we have perpendicular lines or segments coming from the radius. I also know that these radii here, those guys are congruent. When I draw this segment AO, I've made two triangles. The other thing I know is that this segment here, actually AO, is congruent to itself. Maybe I'll just do that. So now you have a triangle on the top and a triangle on the bottom, and we want to see if we can get these guys to be congruent to each other. Remember, congruent triangles, 5 ways to prove them. Side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. This one here, right triangle, the hypotenuse of one, well, it's the same, so those are congruent, and your legs are congruent too. That's it. Hypotenuse leg proves these two triangles congruent. Once we have congruent triangles, all of the other parts are congruent, like these angles here, these angles up here are congruent, and of course, these two tangent segments are going to be congruent. Well, now that we know that those tangent segments are congruent, let's take a look at some more examples. Here we go. These are all fairly simple and they'll all be more or less exactly the same. So we have what looks like this little princess hat, and it can kind of go either direction, left, right, up, down, whatever you want. But just know that the theorem tells us that these external segments are congruent. So you would just write the equation 6x minus 5 equals 3x plus 4. X is to the left, minus 3x. Numbers to the right, plus 5. And x is equal to 3. So this doesn't even say anything on your paper, but I did write find x here, so you can find the value of x. Yeah, they might have you plugging in, and you can find the length of the segment. Who knows? Just go back and read and see what they want. I'll do one more with you. I'll do number 8, because there's an x squared, and sometimes that freaks us out a little bit, but it's not too bad. Just remember the basics is that these two pieces here are congruent to each other. So we are going to say that x squared minus x, this segment, is equal to this one, 3x plus 5. There's an x squared. I probably have to factor, so I'm going to get everything to the side where x squared stays positive, so minus 3x. That would give me a minus 4x, minus 5. Now it's equal to 0, so I can factor. 2 sets parentheses, x in the beginning of each. I'm multiplying to get negative 5. Multiply to get a negative. Only one way to do that, a positive times a negative. And I'm multiplying to get 5. Only one way to do that, it's 5 and 1. So now I have to decide which one gets the negative. Well, because it's a negative 4, the negative goes with the larger number. Those are my factors. Your answers, remember, are opposite, opposite, negative 1, positive 5. 5 definitely works. 25, that's going to be 20. And if you plug 5 in here, 15 and 5, that's 20. Plug in the negative 1. Negative 1, that's a negative 3 plus 5. Well, that's going to give you 2. If you plug negative 1 up here, well, negative 1 squared is positive 1, minus a negative 1 is plus a positive. Both solutions work. So the two solutions here for x are negative 1 and 5.